Hello guys, so today we're gonna compare programming languages by their performance. We are I am looking at this in full screen so we can better visualize the languages. I was extracting them to a file. So let's start. So this is the n-body problem. Why did I pick this problem? Because this I think illustrates good some aspects of performance, and also it has various implementations. You can go and check for yourself if you want. Here you can find the implementations of each language, which I won't get into details, so I will only talk about the results of this table. So n-body 5 million. So we will focus on this table and also on the next one, which is 500,000. Why? Well, because in this table, lots of languages were timed out, so they don't have performance numbers. They were too slow to even work well in this benchmark. So, well, if we take the smallest score here, the smallest time, C++, for example, here is 167 milliseconds. Again, using 1.5 megabytes of memory. So I would say we don't really care about the number here, but the relationship of this number as a proportionally to these other numbers, right? So for example, I think this implementation should be a optimized implementation. Why? Well, because C++ is popular when trying to do this calculation, so more people have figured out probably ways of making this faster. The compiler, for example, may be optimized for these sorts of tasks. But okay, so in this case, we have 167 milliseconds. So let's see how would that be if we want to know 50% slower, right? So if you want to a number that is 50% larger, basically would be this plus 84. That would be 250-ish. So as you can see, that would be like around here. However, I think these numbers are a bit outliers, maybe because of the implementation, but okay. So we have C++. I will probably increase the size of this. C++ first, then we have Rust, again using a bit more memory. These other numbers we won't really care because they are not really stable when you run a program. This depends on the sometimes on the current load of the operating system, or really, I guess, other factors. So we will care about time and peak mem. Okay, so C++, Rust, C++, Rust, C, Zig. Okay, Zig is fast, as you can see. Rust, C, B, as you can see, the Blang, my favorite language, is here, so not bad. 312, not bad. But the problem sometimes is not really great to use that many, a very, very large set like input right here, because the tiny anomalies sometimes get multiplicated in a single sort of benchmark. That's why we will look later in the smaller, a bit smaller benchmark. Okay, so let's continue. So we have B, as I told you, which is also here. Probably this is C++ without optimizations or without doing clever things. Probably. And the same with C, SIG. Well, as you can see, all of these are fast. The one that I don't know a lot about is this one, Chapel, but I don't want to know more about that just because the amount of memory it uses, 32 megabytes, like 10 times more. We don't like that. So then we have Rust Crystal. Crystal is decent, 3.5 megabytes. NIM, Go, Swift. Swift's a bit more memory here. So probably D also, these fast as well. Okay, so what I did, I was extracting this here. As you can see, I will leave here the fastest result for each one. So the fastest of C++ is that. The fastest for Rust is that. Now we're gonna get the fastest for C. I guess I can move it here. Yeah, that's the fastest for C. So I can delete this, and we will do that. And so we are like cleaning a bit this thing. So as you can see, why I would not choose any of the first three. So those, why I would not choose them. Well, because they are, C++ is not easy to write and it's a bit old. Sometimes the memory problems, the same as C. I actually like C and C styles because my hand, let's say, or my brain, they feel comfortable in those languages because I know them. I don't know C++ that much, but it's object-oriented C, so it's like C plus Java kind of thing. But yeah, and why not Rust? I think Rust is too complicated. I think Rust may be useful for some type of people. I don't think I am that. So we have SIG. Oh, then we have B, as you can see right here. B, which is my favorite, but maybe I get another favorite if B gets beating. Okay, so we will be deleting these guys. NIM, okay, so we found a new one, which is NIM. So our clean table will look great. Now we will delete these again and say, well, Go, why Go? Would I use Go? No. And the answer to that is because, actually two answers. One of them is that for some reason, I guess for profit making, NIM and Rust, they are already there. IntelliJ doesn't have a free plugin, but okay, that's not really, it's an inconvenience and money inconvenience, right? Because you have to pay for it. But okay, let's say that's not the big deal. It's kind of this medium deal. But the problem actually with Go is that it uses too much energy. It uses too much energy, too much watts, too much electricity. Yeah. I found D. Did I have D? Okay, D here at 39. Okay, so that's the problem with Go. And here you have these three new guys: OCaml, Odin, and Kotlin. But this is Kotlin native. as you can see in the compiler section right here, Kotlin native. So we can say that these guys are the winners, let's say. Can I delete this line? No, I can't. But so this, as you can see here, we have a SIG-CC. So the fastest C is compiled with SIG. Okay. So again, why not C++? The reason I'm even bothering in searching for new languages is because I would just stay with C, you know. I like C. The problem is that sometimes it is unsafe and you get segmentation faults. And that is a bit of a problem. I still, love C, but sometimes you want something, newer, that's easier to write and doesn't really have lots of segmentation faults. That's why I have moved my favorite language from C to V. But probably these are not the languages where I coded the most. The languages I coded the most in are Java and Kotlin, but Kotlin JVM actually. And because I am an Android developer, so you may know, go and check my app if you want. I made a fast launcher. It's called Optimal Launcher. You can find it at atomantic.com, like atom and romantic, atomantic.com. Because I think it's not ranking very high on the Play Store. Okay. So, yeah. And also, I have an admiration for D. Why? I was comparing these two languages, D and B, and those two are almost on par. The difference is that the compiler of D, which is not really LDC I'm talking about DMD, but okay, this is another compiler, that's fine. The compiler of D really is smarter, is smart, finds cool optimizations, easy and fast. I mean, that's the thing. This thing finds cool optimizations fast. So it produces fast code fast. This B is also very interesting because this produces not the fastest code fast. I mean, it produces fastest code. The fastest code it can produce, it takes some time. So it takes longer to produce fast code. And I'm talking about compilation, right? The compiler takes longer to produce fast code, but is as fast as D, and sometimes probably a bit faster if it's not producing the fastest code, right? I mean, normal kind of compilation is fast, which is not slow in terms of execution, but not just as fast as when you use the prod flag or as D. When you use the prod flag in B, this is equivalent to D without flags. So, yeah, but again, I will still prefer B just because it's easier to write than D. But maybe for some projects, maybe I prefer D, I don't know. In any case, all these languages here have good performance. Let's go back and look what's below Kotlin, just to see if we maybe we're missing something. So below Kotlin we have Odin, but okay. But why did I have Odin here first? Is that my mistake? What did I do? Okay. Am I looking to right? No, I'm looking at the larger one. That's the reason. So here we have Olin, Kotlin, C sharp. Okay, why not C sharp? Because it used too much memory. You can see right here, and just don't like it. Swift, the same thing. Dart, I mean, it's not really. And then you have all these other guys. These are, I think we have chosen to break the table in the right place. So yeah, we're right with this. We're okay. So, which one should I choose? I mean, what the ones that are promising and new, and I recommend you choosing, are all these. Sorry, or all these ones, actually, all of them, all of this, except these three right here. Maybe if you are a certain kind of person that will benefit from the Rust thing, and you have the patience and the things to learn what it takes to do that, well, maybe Rust. But if you're a simple guy, you you don't like a very heavy backpack, right? You probably will like these ones. I don't know what I'm doing here. I'm trying to change the color of these guys. Font color. We have that. Can we put it green, light green? Doesn't look that great actually, but okay. So these languages right here, these languages, red. Okay, maybe it's because I did the other thing before that. So orange brick. Okay, so these languages are the ones that apparently are the most performant ones. So these are the tools that I would choose. I would choose from these guys. Now, personally, I won't choose Go. I won't choose Go because it uses too much energy. Go uses too much energy, so I wouldn't choose Go. Okay, then from here, the other ones I think are worth testing. I know B is great. I know D is great. I know Kotlin is great. However, not the native one, but the JVM one. But it's nice to type, nice to write. But here you go. What's the difference between them? If we get the fastest here, in this case SIG, 29 milliseconds, and compared to the slowest, which is Kotlin, 44 milliseconds. Kotlin uses a bit more memory, but not that much. Then you can say that is Kotlin in this case is 50% slower than SIG, right? Yeah, but if we take like the medium, like an average of these guys, probably, would be 37. Probably, yes, around here, probably 37. But I think all of them are fast enough for me, for my taste, right? The thing is, sometimes, why did I do this in the first place? Sometimes you're using a tool, but sometimes that tool has limits. So you want to watch out there. Maybe there are tools that have a bit less limits. These are those tools. These guys right here. So which one should I choose? Well, I'll have to test them. But I think I will really delete Go from here just because it uses too much memory. I think I will delete C because it's unsafe, too unsafe. The same with C++, hard to write and unsafe. So then we have Rust. You would say, okay, Rust. Why not Rust? I mean, it's too, as far as I know, Rust is too complicated. But some people may value that. I mean, it's not for me, but maybe for someone out there, Rust is good. I mean, actually, for lots of people, because lots of people use Rust in companies and all that. But I'm not. I'm not one of them. Yeah, because you have to learn and it takes too much time. And I don't like my tools to be that hard to learn. It's just my philosophy. So this is like the ultimate thing. Now the syntax of these guys, we will check the syntax. Okay, so let's first go to Rust, which is for IRS. Okay, so we go for IRS, and right here we can see Rust code. Here you have the architecture. I mean, if I'm writing an operating system, maybe I would like to have this, but otherwise, probably not, right? I don't know, solar mass, days per year. It says unsafe. So it has fn as function. Then it has these things that I don't know what they mean. Position and 256 days, I guess. I don't know. I'm not an expert in this. Inverse distance. Energy, all that. So we have here a loop. Loops are not bad. Not bad. Let. Okay, acceptable. First time actually, I think I'm watching this kind of code in Rust. Okay, main amp args. I don't like this notation, but okay. It's not obvious to me what this does. Maybe if I think about it, maybe I can figure it out, but it's not really obvious. So I won't give it too much time because I actually won't choose it, but maybe for people, I will choose it. Well, now we go to that sig. To that sig, as you can see right here, we found it. To that sig. Okay, already it doesn't have x86-64. That's better, I guess. We have math and says, oh, it loads import this to this function. It's kind of like a namespace or something, right? That not bad actually. I like that. Vector 3, it allows for global variables, which is kind of nice. The first thing, the elephant in the room, of course, let me zoom a bit, is the semicolon. Why do you have to use semicolons? Yes, I would prefer not to use them, but it's not bad. Actually, good surprise. I like the code. Are easy to understand. A pointer, I guess, right? this is the first time I really look at the Seek code, and I find it easier to understand than the Rust code. This set float mode optimized, I don't know what this is. I guess this is, faster something in floating point, I guess. Or I don't know. It uses const. I would like to use something smaller like val, like Kotlin does. But okay, it uses const. It's not bad. It's not bad. Actually, good syntax. Good syntax. So, good. Okay. Now we're gonna look into B. B, 1.b. Well, now I'm familiar with B, right? Because I've coded in B, in previous videos and lots of things. So you have here a const thing, and you define this thing right here. Not bad, not bad. Import math string comp os struct body. You define here immutable, and you define this. I like this syntax a lot. I prefer this syntax. Fn for I and 0 cn. Okay. Probably the loops are too long, but okay. That's fine, I guess. Not bad. Not bad. Direct array access. I don't even know what this means. I guess like direct array access, right? So yes, I like this. This is fine as well. I like both Seek and B. Okay. As you can see right here, they're not that difficult, that different. Advanced. Do we have an advanced thing? Oh, advanced. Here we have. Why the Seek one is smaller? Okay. Square root scale, because it's calling functions. Probably this is the scale functions. Well, the 6 looks better, but it's because the way it was made, right? Yeah, I guess. So those two are great. Let's continue. Nym. 2.nym. 2.nym. Okay. 2.nym. Import math os strutils, not bad. Type body tuple xyz bx by bz mass float 64 and body solar mass 4 pi pi. It's not bad. It's not bad. Jupiter, Saturn. Not bad. Proc, like process, like function. Is this the way you define function? You don't have brackets, so you're indentation based kind of thing. Well, apparently. Well, look, it doesn't look bad, but I have to say I'm not used to this syntax. I'm not used. So it would take me longer to learn this than B or SIG. I think SIG is even more familiar than B. But this one is a bit different because of the indentation and all that. But not that bad. The more cryptic one still is Rust. So that was Nym. Crystal, which is 2.cr. Okay, so let's go to 2.cr. Crystal 2.cr. Okay, let's see what we have here. Alias float 64. What's an alias? Like a const, like a type def f64, like a type def in C, I guess. Solar mass, math pi, Mm, the other one was cleaner, but okay. Def, definition. Oh, this is how you do def and end. Def end, def end. Class, planet, velocity, position, initialize, move from I. Again, it's the indentation which is different. But not that bad either. It's not that bad. But it would take me a bit longer because I'm really used to brackets. Here you have Jupiter, Saturn. Well, this one defines those guys better because you have Jupiter X, Y, Z, B, X, B, Y. It's not bad, but here you define it like cleaner or not, because this may be cleaner, right? And depends on what you want. How does B defines this? Where are those planets in B? They are not here. Oh, these are the bodies. But yeah, they don't have a name per se. So this is the B way. This is the Nim way. This is the crystal way. What about the Sig way of defining planets? This one. I actually like this. It's not bad actually. 6. I mean, good. Okay, let's continue. Okay, our document. Now we have D. 1.D. Okay. D, where are you? 2.D, 1.D. Well, I guess we'll use 1.D. Okay, so 1.D. This is not bad. I mean, bodies, 5 bodies, as you can see right here. Jupiter, Saturn, not bad. I like this. The problem here is you have to end your line with semicolons. That's a bit of the problem for my taste, in my opinion. But the syntax in general is not bad. I mean, it's acceptable, I would say. No, I mean, like C, very similar to C, and Sig is also similar to C. Not bad. Now we have to also test the tooling. For example, how easy is to solve a bug or to find a crash or to debug on each programming language. How much the compiler helps you as well. Okay, so that's D, right? Yeah. Now OCaml 1.ml. Okay. OCaml 1.ml. Let's see. We have to look to all of them. OCaml is like the newest one. Okay. So here, let pi, solar mass, days per year. It's not bad. Planet, mutable. Why not just have a thing like B does with mutable and put all of them there? But okay. Advanced bodies, DT, let. I mean, it's an indentation-based coding. So, yeah. How do you define the planet? X, Y, Z. You can actually define this here, which is not bad. Yeah, so this is indentation-based, I guess. So there you go. There you have OCaml. And actually, it doesn't import anything, right? It just works without importing things. That's interesting. Maybe I'm missing something, but yeah. That's OCaml. Now Odin. I.Odin. Okay. Again, never seen its source code. Odin 1.Odin. Okay, so you import the core formatter, intrinsics, math, string comp, OS, pi, solar mass, days per year. Well, it's not bad, this way of defining, I think. What's this? Is this a constant? A way of defining constant? Again, here these double, colon or proc. It's not bad. It has brackets. Here we have body. We have defined a struct. Decent. I don't like the indentation too much, or the way it's coded probably, but it's decent, I guess. Which one is easier to write, easier to understand? Here you have the body, proc, process, I guess, procedure. Again, not bad. Okay, do we have something else? Oh, Kotlin, 1n.kt. Okay, let's go to 1n.kt. Kotlin, 1n.kt. Oh, I didn't open a new window. Okay, that's fine, because this is the last one. So here we have Kotlin. This one is the one that I've written the most code in. So reading this is like reading my name, This is very familiar to me. Very, very familiar. You use bar when you want non-mutable. When you have mutable, want immutable, and val when you have immutable, like kind of a const, I guess. Then you have an end body system, which is a class. You have an init. This is easier to write, in my opinion, right? Easier to read and to write, probably. Energy double. Not bad. The problem, it's not a problem, but the inconvenience when you write Kotlin native, once I tried, is that you start writing and typing, and then you type something that doesn't exist in Kotlin native, and that only exists in Kotlin JVM. That's like an inconvenience, because you're used to use that, but it's fine, I guess. And there's something cool about this language that no other language on the list has, and that is it has first class support in IntelliJ, because Kotlin is from the makers of IntelliJ. That's good. And I think for all of them, they are, I am not sure for Odin, but for all of them, there are plugins for IntelliJ. How good they are, well, I don't know, but there are plugins for IntelliJ for these languages. I don't know for Odin. That's the only one that I don't know if there's a plugin for IntelliJ. The others have a plugin. For example, the B one, which is the one that I have used the most. It works. It's not the best. It's not as good as Kotlin, but it works. It helps you. You can code actually in there. Probably, having said that, even though it's not the best, I think probably is better than most other plugins, except for Kotlin, of course. Kotlin is first class. But you have to test it. For example, in the case for, I guess, all the others, I think I've made a video like a while back. I think I downloaded some of these guys, but probably have to do it again. And now that I kind of understand it a bit more and all that, but yeah. So this is the languages. These are the as far as I know, the languages that I recommend using. There's a language that's not here that may be useful, that was not here, and that's Julia. I don't know the number here, but I guess would be less than 100, right? I guess. So I guess Julia is fast, and I don't know a lot about Julia. But that's some other language that you may want to look into it. Now, if you want to learn a language that is fast and isn't the fastest out there, I mean, my opinion is that you only have these choices. You don't have more choices than these ones. Maybe for some people Rust, but okay, including Rust if you want. You don't have other things. I mean, of course, C and C++, but I mean, I don't think it's wise to use them, even though I love C. Yeah. So I think something really useful in this case is one, how easy it is to type, to write. The how easy it is to write, that would be one. How easy it is to debug, that would be two. And how easy it is to, if it gives you a bit of a hand, not having to write everything yourself, that would be a nice plus. Because in C you have to write everything yourself, right? Of course there are libraries and all that, but it's not really from the language. So I guess this video ends here. I hope you liked it. I have not seen lots of videos talking about like compressing and actually showing the languages and how fast they are, and actually trying to include all of them, all the fast ones and the non very old ones. Well, I mean, you can make a screenshot of this. I think would be a nice screenshot that can help you choose, because maybe it will take some time if you want to test all of them. Probably will take you a couple of weeks, right? Probably a couple of months even. But if you really want to find like the right glove for your hand, like the right tool, because language is something that you use a lot, right? It's the main tool for creating software. So probably it's worth finding a good one, someone that fits you. And if you like fast things, you have these choices: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10, actually. 10 choices. I hope I can soon upload a video comparing these guys a bit more in depth soon. But, and yeah, I mean, right now, the ones that I like the most were RB, the one that I already knew. SIG and D are easy again. Kotlin is also easy, and I guess Julia is kind of interesting if you want to do scientific computing. Also, for that, it's good. But the other ones like NIM, Crystal, OCaml, and Noding, those are like pretty new for me, and I know almost nothing about them. So again, thanks for watching. I hope you enjoyed it. Share, subscribe, like, comment, and I see you on the next one.